Greetings to all. Today I will tell you 4 mysteries of our universe. Enjoy watching. The strangest question in science. Why does the universe have laws? Imagine you launch a complex computer game. It has its own rules, a bullet flies in a parabola, water flows downwards, and the character cannot walk through a wall. The question, why, sounds silly here, because a programmer wrote that code. But now let's ask the same thing about real space. Why does the entire universe, from an atom to a galaxy, have laws? Who was that programmer? Or maybe there are no laws at all. Let's figure it out step by step. First step, what do we even call laws? First, an important clarification. When a physicist says law, he does not mean a legal code. Newton's law or the law of conservation of energy is just a brief formula that reliably predicts what will happen. For example, 2 stones in the universe always attract each other with a force that depends on their mass and distance. This happens near Earth, near a distant star, and 10 billion years from now. Scientists record this regularity. But why regularity exists, science is silent. It answers the question, how, not why. This is important, because many people confuse the description of a phenomenon with its cause. Second step, the religious answer, a legislator. The oldest and most intuitive answer, laws exist because someone created them. The cosmos is not on its own but obeys the will of a higher intelligence. Just as a clock will not start ticking on its own without a maker, the universe could not work without a creator who set the physical constants. In this view, laws are not an accident but a deliberate design. Weak points. Firstly, this is not testable by science. Secondly, the immediate question arises, who created the creator? And by what laws does he himself live? Furthermore, if laws are perfect, why is there quantum uncertainty in them? Third step, the anthropic principle. Laws might not have existed. Modern cosmology offers a different twist. Imagine that laws do not exist and total chaos reigns. Then, a second after the Big Bang, nothing would have formed, neither particles nor space. But we are here. That means we are incredibly lucky. The anthropic principle says, we see exactly these laws because only under these laws could an observer who asks this question appear. If gravity were slightly weaker, stars would not ignite. If slightly stronger, the universe would have collapsed in the very first instant. We live in a narrow, life zone, like a planet at an ideal distance from its star. But this does not explain why the zone exists. It merely states a fact. Fourth step, a radical idea, there are no laws at all. The next step is philosophy. What if laws are just an invention of the human brain? The brain loves to find patterns even where there are none. We see an apple fall 1,000 times and say, the law of universal gravitation. But the universe is not obliged to follow our formulas. It simply behaves in a certain way right now. And we call that behavior a law. If gravity starts working the other way tomorrow, the law would disappear, but the universe would not be destroyed. From this point of view, the question, why does the universe have laws, is like asking, why does water have a wet shape? The shape is not a property of water, but of our perception. Fifth step. Mathematical inevitability, no other option is possible. The boldest and most abstract answer from mathematical physicists. They say, a reality without laws cannot exist. Because reality and chaos are opposites. If you have anything that exists, it already possesses properties. And any properties obey logic and mathematics. For example, even in a complete vacuum, the law of the excluded middle applies, something either is or it is not. That is already a law. It turns out that laws are not a whim of nature, but the only possible way for anything to exist. In this sense, the universe could not be lawless, just as a triangle cannot be a quadrilateral. Conclusion, there is no answer, but that is normal. So, we have four pictures: a divine legislator, cosmic chance, the anthropic principle, human projection, there are no laws, only behavior, and mathematical necessity. Science cannot yet choose between them. Perhaps the answer lies in a future theory of quantum gravity. Or perhaps the question, why are there laws, lies beyond the boundaries of science, in metaphysics. And that is normal. Sometimes it is more important not to find the answer, but to understand why we are even capable of asking such a question. Is there a possibility that our universe is inside a black hole? We are used to thinking of black holes as terrifying objects somewhere far away, in the centers of galaxies. But what if we ourselves live inside one of them? What if our universe, with all its stars, galaxies, and us, is the interior of a giant black hole that lies in another, parent universe? This idea sounds crazy, but it has serious scientific grounding. It was developed by physicists Lee Smolin, Nikodym Poplawski, and even Stephen Hawking himself in some of his works. Let's figure out why this is possible. The first and strongest hint is an astonishing numerical coincidence. Any black hole has an event horizon, a sphere from which nothing can escape. The radius of this sphere is proportional to the mass of the whole. Now let's look at our universe. It also has a cosmological horizon. The distance beyond which we cannot see objects because light from them has not had time to reach us during the lifetime of the universe. If we take the mass of the entire observable universe and calculate what size a black hole with that mass would have, we get a number very close to the size of our cosmological horizon. This does not have to be a coincidence. This is exactly what the model would predict if we lived inside a black hole. An internal observer would see a boundary beyond which information cannot penetrate, precisely at that distance. In Einstein's classical theory, inside a black hole, matter falls into a singularity, a point of infinite density. But this means the theory stops working. If we add quantum effects, the singularity may disappear. Instead, a bounce occurs. The infalling matter does not compress into a point but, having reached a limiting density, begins to expand. To an external observer, this looks like a black hole frozen forever. But to an internal observer, this is the birth of a new universe, the Big Bang. That is, the moment of singularity in the parent universe is the moment of the Big Bang in ours. Time flows differently inside, billions of years inside could be an instant outside. If we are inside a black hole, then why are we not torn apart by tidal forces? Because the hole is incredibly huge. Imagine. The larger the black hole, the weaker the tidal forces at the horizon. For supermassive holes at the centers of galaxies, a person crossing the horizon notices nothing. And for a hole the size of our entire universe, the tidal forces at its horizon are practically zero. We live in a flat spacetime, as measurements confirm, and inside a sufficiently large black hole, spacetime also appears flat, just as the surface of the Earth appears flat to a pedestrian. Moreover, we cannot go outside. This is forbidden by the horizon, but inside we have complete freedom. We cannot even know whether an external universe exists, because no signal from there can penetrate inside.
Is there life beyond Earth? The question of life beyond Earth has fascinated humanity for thousands of years. But 100 years ago, this was pure philosophy. Today, it is a field of serious science, astrobiology. We do not yet have a single ironclad proof of the existence of aliens. But we do have powerful arguments that we are not alone. Or, conversely, that we are unique. Let's look at the facts, not at fiction. Consider this. Just in our Milky Way galaxy, there are about 100 billion stars. And the number of visible galaxies is roughly 2 trillion. Most stars have planets. The latest data from the Kepler telescope tell us that 1 in 5 Sun-like stars has an Earth-sized planet in the so-called habitable zone where temperatures allow water to be liquid. Multiply that, tens of billions of potentially habitable worlds in our galaxy alone. If life were to arise on even 1 in a billion such planets, there would be millions of civilizations in the universe. From a purely statistical point of view, Earth cannot be unique. It was once thought that life required sunlight, oxygen, and a mild climate. But in recent decades, we have found extremophiles on Earth. Organisms living in boiling acidic springs, in permafrost, in nuclear reactors, on the ocean floor near black smokers at temperatures of plus 400 degrees Celsius, where there is no sunlight and energy comes from chemical reactions. If life is so tenacious, then it could exist beneath the icy crust of Jupiter's moon Europa, in the methane lakes of Titan, in the clouds of Venus, where the temperature and pressure at the surface are hellish, but at an altitude of 50 kilometers conditions are quite Earth-like. We already have candidates right here in the solar system. If life is supposed to be widespread, why have we not yet received a single radio signal from intelligent beings? This is the famous Fermi paradox, which physicist Enrico Fermi phrased as, "So where is everybody?" There are many explanations. Perhaps intelligent life is an extremely rare accident that almost never arises. Or it does arise but quickly self-destructs, nuclear war, climate catastrophe. Or we are looking in the wrong place, aliens communicate not by radio but by lasers or neutrinos. Or maybe they are out there but deliberately hiding, the zoo hypothesis. Or, the most troubling, we are the first in the universe. Quite recently, new data have emerged. Spectroscopy of exoplanet atmospheres has made it possible to detect biosignatures, gases that are not produced without life. For example, in the atmosphere of the planet K2-18b, 120 light-years away. The Webb telescope in 2023 found hints of dimethyl sulfide, a gas that on Earth is emitted only by ocean algae. The result has not yet been confirmed, but the intrigue remains. And in the solar system, the Europa Clipper mission, launched in 2024, will study Jupiter's icy moon in detail, and in the 2030s, drilling through the ice is planned to retrieve water samples from the subsurface ocean. The chances of finding at least bacteria on Europa are considered very high. The direct answer to the question, is there life beyond Earth, today is, we do not know for certain. But we do know that the conditions for it are common. We know that life on Earth arose surprisingly quickly as soon as the planet cooled down. This suggests that it is not an accident but a regularity. And we are very close to finding it in our own solar system, beneath the ice of Europa or in the methane of Titan. Even if it is microbes, that will forever change our place in the universe. We will cease to be unique. As for intelligent life, that question remains open. Perhaps we will hear a signal tomorrow. Or perhaps we are the voice of the cosmos.
Why we will never be able to reach the edge of the universe. When we look at the starry sky, it intuitively seems that somewhere far, far away there is a boundary, the last star, and beyond it, emptiness. But modern physics says, reaching the edge of the universe is impossible. And it's not because our rockets are too slow. Even if we invented a starship traveling at the speed of light, you would still never reach the end. The reasons are deeper and much more interesting than technical limitations. They concern the nature of space, time, and the Big Bang itself. First reason, expansion faster than light. The universe is not static, it is expanding. And not just expanding, but accelerating. Imagine you are walking on a moving escalator in the opposite direction. If the escalator speeds up, you might stay in place or even move backwards. The same thing happens with galaxies. The most distant ones are receding from us at a speed exceeding the speed of light. Yes, this does not violate the theory of relativity, because space itself is expanding, not the objects within it. The light you send toward that edge will travel, but the space between you and the target will stretch faster than the photon moves. You will never catch up to the horizon, it runs away faster than you can chase it. Second reason, the universe might not have an edge. What if there is simply no edge at all? This is not an evasion, but a real scientific scenario. The universe could be infinite, then the question, reach the edge, is as meaningless as, find the largest natural number. But even if the universe is finite, like the surface of a sphere, it has no boundary. You will never hit a wall, you will fly on and, after an unimaginable time, return to the same point from which you started, like Magellan circling the Earth. only in three-dimensional space. So there is no edge in the usual sense of the word, there is a finite volume without boundaries. Third reason, the cosmological horizon as a fundamental barrier. There is the concept of the cosmological horizon. It is a sphere beyond which light from objects has not had time to reach us during the entire lifetime of the universe. But the horizon is not a physical wall. It's just that objects beyond it are moving away from us faster than light due to expansion, and their light will never reach us. Moreover, because of accelerating expansion, dark energy, the horizon does not expand with us, on the contrary, galaxies constantly disappear behind it. In many billions of years, our night sky will become almost empty, only the stars of our local group, bound by gravity, will remain. Travel to something that is no longer within sight. Impossible. Fourth reason. We cannot outrun our own past. Even if we discard expansion and imagine a static, infinite universe, there is a fundamental limit, the speed of light. To reach the edge, if there were one, you would have to travel faster than light, which is forbidden by physics. But that's not the main point. Cosmologists often joke, the edge of the universe is a place we look at when we look into the past. The farther away an object, the older the light we see. The theoretical edge is the moment of the Big Bang, 13.8 billion years ago. But this is not a place in space, but a moment in time. Going there would mean reversing time, which is impossible. So, 4 pillars, expansion faster than light, the absence of a boundary as such, the cosmological horizon, and the ban on superluminal speed. But there is also comfort in this unreachability. If we could fly to the edge, beyond it would be either emptiness, or another universe, or a wall. But that would break our physics. The fact that the edge is unreachable is not a bug, but a feature of our reality. The universe is structured in such a way that it has no outskirts you can point to. And this makes it truly infinite in our perception, even if mathematically it is finite. We will never run into a fence, there will always be a new horizon. Perhaps that is the ultimate freedom. Thanks a lot for watching, see you soon.